Security implementations in storage networking. The basic security implementations are FCSAN, IPSAN environment, NAS. FCSAN. Traditionally, FCSANs enjoy an inherent security advantage over IP based networks. An FCSAN is configured as an isolated private network with fewer nodes than an IP network. Consequently, FCSANs impose fewer security threats. However, scenario has changed with storage consolidation and larger SAN design that span multiple sites across the enterprise. FCSP, Fiber Channel Security Protocol, which aligns security mechanisms and algorithms between IP and FC interconnects. This standard describes guidelines for authenticating FC entities, setting up session keys, negotiating parameters required to ensure frame by frame integrity and confidentiality. FCSAN security architecture. Storage networking environments are a potential target for unauthorized access, theft, and misuse because of the vastness and complexity of these environments. So, security strategies are based on the defense in depth concept, multiple integrated layers of security. Ensures that the failure of one security control will not compromise the assets under protection. We have a diagrammatic representation for SAN security architecture, which is defense and depth. We can have a look over it. Two-factor authentication. Table provides a comprehensive list of protection strategies that must be implemented in various security zones. Some of the security measures are listed in table, and it is not specific to SAN but are commonly used to data center techniques. Two-factor authentication is implemented widely. In a simple implementation, it requires the use of username, password, an additional security component such as smart card for authentication. We have a tabular column with security zones and protection strategies. Basic SAN security mechanism. Mostly used SAN security methods. LAN, securing switch ports, switch wide and fabric wide access control, logic partitioning of a fabric. LAN masking and zoning. LAN masking and storage arrays mask the LANs presented to a front end storage port based on worldwide port name of the source host bus adapter. Also can be done on the basis of source FC addresses. Offers a mechanism to lock down the FC address of a given node port towards WWN. Worldwide name is a vendor supplied 64-bit globally unique identifier number assigned to nodes. WWPN zoning is the preferred choice in security conscious environment. Securing switch ports can be implemented using following methods: port binding, port lockdown and port lockout, persistent port disable. Port binding. It limits devices that can attach to the particular switch port. A node must be connected to its corresponding switch port for the fabric access. It mitigates but does not eliminate. It is WWPN spoofing. Port lockdown, port lockout. Restricts the types of initialization of a switch port. Typical variants include: port cannot function as an E port, cannot be used for ISL. Example to a rogue switch. Port role is restricted to just FL port, F port, E port, or some combination. Persistent port disable. Prevents a switch port from being enabled even after a switch reboot. Switch wide and fabric wide access control. As organizations grow their SANs locally and over long distances, there is a greater need to effectively manage SAN security. Network security can be configured on the FC switch by using access control lists, on the fabrics by using fabric binding. Access control lists typically implemented policies which may include device connection control, switch connection control. Device connection control prevents unauthorized devices from accessing the fabric. Switch connection control prevents unauthorized switches from joining the fabric. Fabric binding prevents unauthorized switch from joining any existing switch in the fabric. RBAC specifies which user can have access to which device in the fabric. It ensures the authorized membership data exists on every switch, and any attempt to connect any switch in the fabric by using an ISL causes the fabric to segment. Role-based access control provides additional security to a SAN by preventing unauthorized activity on a fabric for management operations. It enables a security administrator to assign roles to users that explicitly specify privileges or access rights after logging into the fabric. For example, the zone admin role can modify the zones on the fabric, whereas a fabric user may view only fabric related information such as port types and login nodes. Logical partitioning of a fabric vSAN. Dividing a physical topology into separate logical fabrics, where the administrator allocates switch ports to different vSANs. A switch port can be in only one vSAN at a time. Each vSAN has its own distinct active zone sets and zones. Fabric events in one vSAN which are not propagated to others. Role based management can be on a per vSAN basis.